Computer mathematics. Now, today we are looking at the 2025 Columbia University Integration Bee qualifying round. This part of the Integration Bee had 24 problems. Today we'll just focus on the first 10 problems. We'll go quickly through each problem and see how one may be able to solve that. These are the set of problems that were included in the first batch of the 10 problems. So we're going to go through each and every problem shown here, and I hope you do enjoy as we go through these problems. We'll try to keep at least or at most a minute on each problem. Hopefully we do a better job on that. We may spill over a little bit, but that our goal is to be efficient and also just explain some of the intricacies in each problem. So without much ado, let's jump into solving these problems. First problem, this is actually a very simple problem. The indefinite integral of sine x plus cosine x. So we can go item by item. The integral of sine x is negative cosine x. The integral of cosine x is sine x, right? And then we have our integration constant. And that, ladies and gentlemen, is our answer. So nothing really complicated on that. And then let's move forward and solve the next problem. Problem number 2, what I'll choose to do here is use integration by parts. And what I'll do is I will express sine x as the derivative of negative cosine x, right? And we know that with integration by parts, if you have a product of capital V and derivative of capital U, the integral there is uv minus u, the derivative of v. So this being our formula for integration by parts, we see that this here is our v and this here is our capital U. So our uv is going to be x cosine x plus integral of we'll keep cosine, negative cosine x, and that's why this negative and this negative interact. We have a positive here, and then the derivative of cosine of x is going to be 1, so we are just going to have cosine x integrated. So this becomes negative cosine x plus sine x plus the integration constant. And that there, ladies and gentlemen, is our answer. Okay, so let's go forward to problem number 3. Problem 3 is very interesting, and some people may want to just bulldoze through this problem, but the trick really lies in substituting the middle part of the integrand here by saying let u be equal to x minus 1 such that du dx equals to 1, and that means that you can use du to substitute of dx. And then when x equals to 0, what that means is that u is equals to negative 1. When x is equals to positive 2, u equals to positive 1. So our integral in the u domain becomes integral from u equals negative 1 to positive 1 of u plus 1 u minus 1. And that corresponds to x minus 1, and x minus 2 respectively. And then in place of dx we have du. As we can see here, we have difference of 2 squares, so the problem becomes integral from u equals to negative 1 to positive 1 of u squared minus 1 times u, which equals to integral from u equals to negative 1 to positive 1 of u cubed minus u, and that becomes integral, or the integral results to u to the power 4 over 4 minus u to the power 2 over 2 with the limits negative 1 and positive 1. Since 1 to the power 4 is same as negative 1 to the power 4, and 1 squared is same as negative 1 squared, the answer here is just going to be 0. And that is the answer that was expected. As simple as that. So on the next problem, problem number 4, we do have u minus 1 to the power 2025 as the integrand. The quickest thing for me really to do is to say let u equals to x minus 1, such that du dx is equals to 1, and so we can substitute for dx with du, right? And so our limits when x equals to 1, we see that u is equals to 0. When x equals to 2, we see that u is equals to positive 1. So now we have integral from, in the u domain, from 0 to positive 1 of u to the power 2025, which is equals to u to the power 2026 over 2026, 0, 1, which means that we're just going to be remaining with 1 over 2026 minus 0 over 2026, which is equals to 1 over 2026. And that is the answer that was expected. Okay. Next problem, we're going to use the trigonometrical identities, where we'll say that sine A plus B plus sine A minus B is equals to twice sine A cosine B, right? And so A could be 3x and B could be 2x. And using this identity, we can say this is the same as the integral of a half sine of 5x plus sine of 3x minus 2x as A minus B, which is just x. And so this becomes half in bracket negative 1 over 5 cosine 5x minus cosine x plus the integration constant. So this just becomes 1 over 10 cosine of 5x minus a half cosine of x plus the integration constant. And that is hopefully the answer that was expected. So let's continue to the next problem. So with this problem here, we are just going to deal with it in a very fast way. What we see here, we can re-express this as the integral of cosine squared minus sine squared, and using the difference of two squares, that's the same as cosine squared x minus sine squared x times cosine squared x plus sine squared x, right? And this here is equal to 1, so we are left with the integral of cosine squared x minus sine squared x, and this is the same as cosine 2x, so this becomes a half of sine of 2x plus the integration constant. And that is all that was expected. So let's go to the next problem. So here, this is very interesting. It's very obvious, but how I choose to look at it is I would end up plotting. We have x squared, and then we have y equals to 9, and this is y equals to x squared. And you can see that from 0 to 3 here, this curve x squared is minimum. Above it, y is is minimum. So in other words, our problem becomes integral from 0 to 3 of x squared plus integral from 3 to 25 of just 9. And that becomes x cubed over 3 from 0 to 3 plus 9x from 3 to 25. And so this becomes, we have 3 cubed, which is going to be 27 over 3, which is going to be 9, plus 9 times 25 minus 3, which is 22. So this becomes 9 times, so 22, that is 180 plus 18, which is 198. So 9 plus 198, which is just going to be 207. And that was the expected answer. Okay. This problem is actually fairly simple. I'll choose to use two approaches. One is just by a graphical interpretation, and then the next one would be to do the hard-coded calculation. So what we do here is we're going to just plot tan cube x. So we have asymptotes, negative pi over 2, pi over 2, and this is y, this is x. And tangent of x is something that is like that, asymptotic around negative pi over 2 and pi over 2. And then when you cube it now, we have something like that. That is, that, goes to infinity faster than tangent of x. Now at pi over 4 negative and then at pi over 4 positive, we see that the area under the curve enveloped by the x-axis, they are symmetrical around each other, but one is negative and one is positive. So we quickly just find that the answer is 0. So that is the first way of looking at it. The next way of doing it is I'll just say this is an integral from negative pi over 4 to pi over 4 of tangent of x times tangent squared of x, and this would be equal to negative that tangent of x sec squared of x minus 1 is the same as tangent squared of x. So this becomes negative pi over 4 to pi over 4 sec squared of x tangent of x minus tangent of x, right? And so here we quickly find that this is integrated is a half of sec squared of x minus, so this becomes positive log of cosine x from negative pi over 4 to pi over 4. Now what we see here is that pi over 4, negative pi over 4 will bear the same value for half sec squared x, but also since cosine of a negative is the same as cosine of a positive, this is the same as 0. So the upper limit and the lower limit substituted onto whatever we've obtained here would be the same, and so it all collapses to 0. And that is the answer that was expected. Easy. We may want to just try to re-express things a little bit. So here I would say this is the same as integral from x equals to 0 to x equals to 9 of, here I would see 81 times 25 minus 25x squared. So we can pull out 25 so that we have 5, 0, 9, integral of 9 squared minus x squared, and we'll just say let x be equal to 9 sine theta such that dx d theta is equals to 9 cosine theta, and so dx can be substituted off with 9 cosine theta d theta. So this is the first thing, and then limit when x is 0 goes to 0, that is 0 divided by 9, and arc sine of 9 means that theta is, arc sine of 0 is going to be, theta is going to be 0. When x is equals to 9, 9 divided by 9 is 1, so arc sine of 1, so theta is going to be pi over 2 rather. Okay, and so our problem now becomes integral from 0 to pi over 2. We have 5 out here, and then we're going to pull and then we have 9 squared minus 9 squared sine squared theta times 9 cosine theta d theta. Okay, so since our problem had come to a point where we had 0 pi over 2 integral of 9 squared sine squared theta, 9 cosine theta, so we can pull out the two 9's, so we have 5 times 9 times 9, 0 pi over 2 into 1 minus sine squared theta cosine theta. 1 minus sine squared theta is cosine squared theta, square root, we get cosine theta. So we have cosine theta, and so here we have 405 0 pi over 2 cosine squared theta, which is 405 over 2, 0 pi over 2, and we have cosine 2 theta plus 1, right? And so let's continue and see how we may. So since our problem became 405 over 2 integral of cosine 2 theta plus 1, 0 pi over 2, this becomes over 2, and we have positive a half sine 2 theta plus theta, 0 pi over 2. We can see that when theta is pi over 2, sine of pi over 2, sine of pi over 2 times 2 is sine pi, which is 0. At the same lower limit also, sine of 2 times 0 is going to be 0, so we are left with 405 2 times pi over 2, which is 405 over 4 times pi, and that is the answer that was expected. It's very interesting. What we'll do here is let's just spread out the tangent squared of x in such a manner that what we have here is sine of x times cosine of x times sine squared of x over cosine squared of x, and as you can see, this squared and that would go, so we are left with sine squared of x times sine x over cosine of x, and sine squared of x is the same as 1 minus cosine squared of x times obviously tangent of x here, which is the same as tangent of x minus sine of x times cosine of x, and this is the same as integral of tangent of x minus a half of sine of 2x, which is the same as negative natural logarithm of cosine of x plus a quarter of cosine of 2x plus the integration constant. And that, ladies and gentlemen, was the answer that was being sought for.